Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our Sortint function. This is part of a larger series of videos focusing on different sorting algorithms as well as their applications. The first thing to note is that if you're using an older version of the file, you will probably want to update to this newer function signature. I've rearranged a couple of the arguments as well as included an argument to be able to further streamline these functions to be used in later videos. So we'll start by taking a look at our sortint function, and you can copy the prototype and then go back down to the bottom of your file and paste the prototype and go ahead and extend it into a function. We can go ahead and add the comments to include both the name and the description of what we're about to do. We'll keep this simple in that for the name, we will simply use the function signature. Now, this video assumes that you have already built your sort version 1, version 2, and version 3, as well as worked on the cleanup and comparing these three sorting algorithms. The first thing to note is that unlike the earlier examples, this function has no file I/O, meaning it expects that you have already loaded the data into an array, and we are simply focusing on sorting that array. The second thing you'll note is that the numbers array or vector is a constant, meaning that we will make no changes to this array, but rather we are going to utilize this locations array or parallel array to be able to determine how to ultimately rearrange the numbers array once the function is done running. This is useful when you have multiple parallel arrays that all share the same indexing. The only assumption that we are going to make is that our n dictates the number of usable elements in both the numbers array as well as the locations array. The last thing to note is, like the earlier functions, we have an order enum that allows for us to sort either ascending or descending. Now, since we are not going to be dealing with the file I/O portion, we will not need to create file pointers either for reading and for writing files, as well as not needing the chunks temporary variables associated with reading the data out of the file. Instead, we are going to focus solely on the sorting algorithm, with the biggest distinction being that we will not modify the original numbers array, but rather focus on the locations. So the first thing we want to do is to go ahead and sketch out a few of our temporary variables. And to begin with, we want to have a temp index that is going to be a integer. We also want to have a flag called found that we're going to use to determine whether we have found a low or high value, a new low or high value. We also want to specify the found index as well as the found value. Additionally, we also want to have an integer that will keep track of our low index, in other words, where we start in our array, as well as an integer that keeps track of the search index, or which values we are comparing to the current found value. And then lastly, to keep in line with some of our earlier videos, we would like to find out or keep track of how many items were out of place in our array. And so to do that, I'm going to create one more temporary variable, or one more index, essentially count variable, that I'm going to call change counter. Now, we can go ahead and initialize some of these, particularly our change counter variable. We want to initialize this to 0. For some of the others, we are going to wait until we create our for loops. But the first thing that we want to do is handle the order enum. So to begin with, we set this up with a if statement that simply looks to see if the order is ascending. And if it is ascending, then we sort from low to high. Else if order equal to descending, we sort from high to low. And then lastly, under the else, we simply provide a message back to the user that indicates that we have a unhandled enum. Now, the only other thing we have to do in our setup is simply provide a return value. And so in this case, what we want to do is we simply return the number of changes that needed to be made in our array. We could return exit success and exit failure. This would also be useful, but the change counter, or the number of things that needed to be changed in the array, can be helpful when deciding whether or not the array, or the parallel arrays rather, that are related to our numbers array also need changing. In other words, if our numbers array is already in the correct order, there will be 0 changes. So in this case, we simply want to return the value of our change counter. Now, as I mentioned, for this one, we're going to focus in on the ascending, and then everything that we do for the ascending, then we will carry on to the descending. However, there is going to be one difference, as I mentioned, from our earlier sorting functions, because we will not have the luxury of modifying our numbers array. Instead, what we're going to do is we're going to use our locations array, which is essentially going to capture the current location of a value to be able to access the values in the numbers array. So essentially, we're going to use the return value from one array to be able to determine the found value. So to begin with, the first thing that we want to do is we want to initialize found equal to 0. The next thing we want to do, rather inside of our for loop, my apologies, I got ahead of myself here. So the first thing we want to do is we want to build our for loop, and we want to start off at the low index, meaning that we want to start off at the lowest value in the array, or the 0 index, and we want to continue looking through the array up to the value of n-1, or count -1. If you're unfamiliar with why we go to n-1 or count -1, I encourage you to watch the sort version 3 video, as this will be the algorithm that we are using for this example. And then we continue by indexing our low index, or incrementing our low index. Now we want to initialize found equal to 0, or found equal to false, because we always assume that we have not yet found a new low value. The next thing we want to do is we want to capture the low index and store it in the found index. So in other words, we always assume that the lowest value is found at the lowest index if we're looking for ascending. We then want to capture the found value. And once again, this is a convenience variable, but this gives us a great opportunity to see how we are going to nest our arrays. So we start off by utilizing the numbers array. And normally we would specify the numbers array and the found index to determine the found value. But the locations array essentially holds a mapping between the original location and the final location of the data by virtue of the fact that it starts off as a copy of the index into the values for the locations. In other words, locations square bracket 0 is equal to 0, locations square bracket 1 is equal to 1, all the way up to n minus 1. In other words, locations square brackets 99 is equal to 99. And as we move these values around, we simply rearrange the values in the locations vector, thereby keeping track of where the original value came from. And so in order to leverage that, instead of saying numbers, square brackets, and then simply putting in the found index, what we are instead going to do is we're going to nest in this our locations array. And from the locations array, we are going to pull out the value located at the found index. Now, since the original locations array has the value of 0 at the location 0, this simply means that we pull out the value at the 0th location in the numbers array. So initially, it doesn't look any different than our earlier examples. From here, we simply build our inner for loop using our search index. And we start off our search index at our low index plus 1. Once again, we've taken a look at this in our version 3 of our sorting algorithm. And then we continue with the search index all the way up to the nth value. And then we simply increment our search index. From here, we have an if statement that simply compares the value in the numbers array to the current found value. However, just like we nested the numbers array, or rather the locations array inside the numbers array in order to determine the found value, we are going to do the same now when we are doing our comparison. So essentially what we're going to do is we're going to say numbers square brackets locations and then use the search index to find which location we are looking for inside the numbers array. So essentially, locations square brackets search index is going to tell us what is currently at that location inside the numbers array. And we compare that then to the found value. And as I have mentioned before, the found value is merely a convenience variable. We could just as easily use the numbers square brackets locations square brackets found index. If this statement is true, this means we have found a new low value. Else, we need to keep looking. Well, if we found a new low value, first thing we want to do is we want to set our flag to true or found equal to 1. The second thing we want to do is set our found index equal to our search index. And lastly, we want to update our convenience variable or our found value variable utilizing the numbers array. However, also nesting in the locations array, but once again, using the found index. Now, if we have successfully managed to make it through our inner for loop, We want to now check to see if found equal to true. In other words, did we actually find a new low value? And what we want to do now, if we did, is we want to handle swapping not the values this time, but we want to handle swapping the indexes in the locations array. And to do that, we simply use the temp index variable, much like we used the temp value variable in the sort version 3. And what we do is, instead of leveraging the numbers array, we simply leverage the locations array to capture whatever was in at the low index location. The second step is to take whatever was at the found location and put it in the low index location. So to do that, we simply say locations, square brackets, low index is going to be equal to whatever is at the original locations, or the locations, square brackets, found index. The third step to complete the switch is simply to put whatever was at, or rather in, the temp index variable back into the array, the locations array, at the found index. So this completes that swap. Remember, we need that temporary index, or that temp variable, to be able to accommodate our swap. The only thing we have left to do is to complete our if else, and for the else, then we simply do nothing. Now, as I mentioned earlier, we would like to keep track of the number of out of place values in our array. And to do that, every time we determine that we have a new value, in other words, a new value that's less than the existing found value, we want to simply increment our change counter. This then allows for us to return the number of out of place values in our array. Once again, the only difference between the ascending and descending is merely the change in sign. So before we do anything, let's go ahead and build it. Let's see if we have any errors in our ascending code. And if we don't, copy and paste it into our descending branch and make our change. You can go ahead and rebuild it now, just to verify that we did not introduce any new errors, as well as change the comment where we have found a new high value. At this point, we can get back to our main and test our new sort int. As I mentioned earlier, this one's going to require a little more buildup than our previous examples, because in our previous examples, we simply passed an input file name and an output file name. It did the sort and wrote the output to the output file. Instead, what we want to do is we want to go ahead and read in some data, in this case from our sample01.txt, but we have to do all of the work prior to passing the array to the function. So what I would like to do is I would like to start off by creating some temporary variables inside of another else if. And specifically, in order to set up this else if, we need to think about the number of arguments that we will need. And so the goal here is that I want to test my sort int function. And so really the only argument that I need will be that switch. I could also provide a file name to be able to determine the input file. So at the very least, the executable, the first switch, and the file name for a total of 3 arguments. So if my argc is equal to 3, and using my string compare I, if I compare argv square brackets 1 to the slash sort int switch, which matches my function, if that is equal to 0, and once again, we want to make sure that we match our parentheses, we're going to assume then that our argv2 is simply our file name. So let's go ahead and set up some temporary variables. The first temporary variable we are going to need is going to be our input file pointer. We're also going to need some place to store our values. And in this particular case, they're going to be integers. So I'm going to create a temporary array that I'm going to call unsorted underscore numbers. And I'm going to go ahead and hard code for this example 100. I then want to go ahead and generate, or rather utilize, a temporary variable called index. And I also need another array for that parallel array called locations. And the locations must be the same size as our unsorted numbers. Now, fast forwarding just a little bit ahead, we will also need to have a sorted numbers array, and we're going to go ahead and make those 100 as well. Now, from here, we simply open, using fopen, our input file, whatever happens to be passed in our argv2. That's not exactly very secure, very safe rather, meaning that we are just blindly assuming that our argv2 is a valid file name, but we want to open it for reading. And then at the very least, what we're going to do is we're going to check to see that our input file pointer is not equal to null. At this point, we simply want to initialize our index. We'll set up a while loop using fscanf. We want to use the input file pointer. And what we can do is we can actually use the address of the unsorted numbers square brackets index directly. We do not actually need to have a chunks variable. And more importantly, for the second input argument, we want to specify the %d, which indicates that we're going to be reading in an integer and storing it in the value, or rather at the location in the array that we specified by the index. And assuming this is not equal to end of file, at this point, for convenience, we would probably want to print out the index followed by the value that we have pulled out of the file. So index, and then the second value will be the unsorted numbers square brackets index. And then, as always, don't forget to increment your index. Now, the other thing that we will want to do here is, because we are hard coding 100, we should also put a and we'll do this first. We'll check to make sure that our index is in fact less than 100, because we do not want to insert more values into our unsorted numbers than what we have allocated. And in this case, we're actually going to check that first to prevent the fscanf function from running unnecessarily. At this point, we can simply close the file. And now what we can do is we can run our sortint. We would like to capture, using a results variable, the results of our sortint and be able to track the number of out of place values. So the first thing we do is we say results equal to sortint. We want to pass as the first argument the unsorted numbers. Keep in mind that we're passing this as a constant array, so no changes can be made to it. For the second argument, we are going to pass our locations array. For the third argument, we're going to hard code the number of values that are in the array to 100. And then as the fourth value, whether we want to sort it ascending or descending. You could optionally include this as a fourth argument when calling your executable and then triage that string. Now, from here, you simply want to printf the number of out of place values and simply provide a %d placeholder followed by a new line, and then we want to print the results. Now, before we go any further, we want to think about this for just a second. Our locations array has not been initialized. And so therefore, when we start swapping around values, we are essentially going to be swapping around garbage. The easiest way for us to initialize our locations array is to do it when we are collecting the values out of the file. And we do this by simply saying locations square brackets index is equal to index. What this merely says is the original location of a particular data corresponds to the index. So in other words, 93 would go into the unsorted numbers and 0 would go into the locations. We would continue to do so all the way through to the end of the file, such that the 99th value in the unsorted numbers would be 73, and the 99th value in the locations array would be 99. Now, after we have ran our results, or excuse me, ran our sortint and captured our results, we would also like to print out the current value in the numbers array, as well as the current value in the locations array. So essentially, what that will do is that will tell us where the value has been moved to. So to start off with, I'm going to simply set up another for loop starting with the index variable. So for index equal to 0, index less than 100, once again hard coded, and then index plus plus. And what we want to do here is build a little impromptu table. So I'm going to make a nice border up here at the top and another one outside of the for loop. And then inside, I'm simply going to printf, in this case, several %ds, starting with the index. But also what I want to print out is I want to print out the value in the original numbers array, as well as the value in the current locations array. So if we were to clean this up just a little bit or to provide a header for this table, let's come along here. We'll print F. Maybe we'll provide an index. And then a little bit further over, this is going to be numbers, square brackets, index, and then locations, square brackets, index. Now, this will take a little bit of cleanup, a little bit of trial and error. Maybe we'll go ahead and add another tab in here, a couple more spaces to break it up. We'll come back to this. But at this point, then the only thing we're missing then is to give this a shot and see how it works. So let's make sure that we've got something to compile. Oh, I forgot to put in my values here. It's giving me a warning. So the first placeholder is going to get index. The second placeholder is going to get numbers, square brackets, index. And the third is going to get locations, square brackets, index. I'm going to save this and going to build it. I believe yes, one more typo, no big deal. This is supposed to be the unsorted numbers. And then let's see here, we build it. All right, so let's come out here then to our command window. And the first thing we want to do is make sure we're in the right directory by typing in dir. You'll see that there are some of my files from earlier runs, but more importantly, what we want to do is we want to run our sortdemo.exe. This time, though, we want to provide it with the /sort_int switch that corresponds to the function, as well as the sample o1.txt. And if I hit enter, I get a lot of information flying by. And let's scroll up and take a look at what we have. So the first thing you'll note is that I am simply reading in the values from the file so that the 0th value corresponds to 93, first value corresponds to 97, all the way down to the 99th value, which corresponds to the 100th row. So at this point, we should feel fairly confident that this works. So if anything, what I'm going to do to reduce a little bit of clutter is I'm going to stop printing out this value. You can choose to continue to print it. It's no problem. I'm going to once again clear my screen. And now what I'm going to do is I'm going to rerun this and we should get our table that we created earlier. And you'll notice that at index equal to 0, the 0th value of our numbers index was 93. I'll tell you what, before we go any further, let's do a little more cleanup because this still looks particularly ugly. And so we'll start off. How about if we add a new line there? And then also what we could probably afford to do is to shift our values over a little bit more. So how about if we add 4 spaces there and 4 spaces there, which should shift that third column over by 8. This should look a little bit better. It's probably still not going to be quite perfect. All right, well, much better. At least we can get the point now. And so we have the 0th index corresponds to the numbers array, or 93, which corresponds to the value in that location. So numbers square brackets 0 is equal to 93. Now, for the locations square brackets index, this is now showing 98. Now, you're probably wondering what in the world that means. Well, it says, what is the value that's supposed to be, or rather, where do I find the value that should be in the 0th location of the numbers array? In other words, if we had sorted it, what value should be there? Well, to find that value, you simply go over to your file and you look at the index equal to 98, or rather row 99 because of the offset. And you'll notice that it's 60. And if you recall, 60 is actually the lowest value in the file. Now, to help you make some sense of this, let's add a fourth column to our table. And this fourth column is going to be a combination or a nesting of the numbers, square brackets, locations, square brackets, index, similar to what we saw inside of our function. I'm also going to extend the borders for our table, as well as add a fourth placeholder of a %d in our table. And this is going to get a little long here. So if anything, what I'll do is I'll bring this on to the next line. But for the fourth value is going to simply be numbers, square brackets, locations, square brackets, index. Now, let's go ahead, once again, unsorted numbers. Let's go ahead and build this. And let's rerun this. Let's see if we've got anything to rearrange here. That doesn't look too terribly bad. I do think we need to move this over a little farther. How about a couple more tabs here? A little bit of trial and error. And better, not perfect, but we can always work with that later. But you'll notice then if you take numbers and you plug in the location that is stored at a given index, so in other words, the integer that is returned from the locations vector, it tells you then at this point, it tells you what is stored at the 98th index, or index equal to 98 rather, of your numbers array. So essentially, this tells you what was originally stored there, and this tells you what should be stored there. Now, how do you use this to reshuffle the array? Well, this is where that sorted array comes into play, and for that matter, any parallel array that you would also need to sort. For example, think Excel, in that how Excel lets you sort a column of data, but also lets you sort the adjacent columns simultaneously. Is essentially what it's doing is it's keeping track of the indexes of that one column and applying those changes to the additional columns. So I'm going to give us an empty line here. And then what I'm going to do is I'm going to start off with another table. And in that other table, what we're going to do is we're going to print out the sorted values. And so to do that, I'm going to build the sorted array, or initialize the sorted array, using another for loop. So index equals to 0, index less than 100, index plus plus. And inside this, I'm simply going to say sorted numbers, square brackets, index is going to be equal to unsorted numbers, square brackets, locations, square brackets, index. In other words, the locations vector tells me where do I need to get the data from? In other words, what row really needs to be there? And so in this particular case, when index is equal to 0, locations, square brackets, 0 is going to return 98, and therefore unsorted numbers, square brackets, 98 will essentially apply 60, or assign 60 to the sorted numbers array at index equal to 0. And to prove that this actually works, what I want to do is inside of this second table, we simply want to build a for loop. So for index equals 0, index less than 100, index plus plus. Rather than a table necessarily, what we want to do is we want to print f, and we're going to play around with this a little bit. How about if we say something like the value %d moved from %d to %d. And then for this now, we want to provide 3 arguments for these placeholders. The first one is going to be the original unsorted numbers, and we simply provide the unsorted numbers square brackets index. Now, for the second value, we want to capture the original location of that value. Well, if you recall, the original location of that value was simply the original index. So in this case, the 0 index corresponded to the first line in the file. So essentially, it started off at the 0th index in the array. That value then moved to another location. Now, if you notice looking at our earlier table, we may not necessarily be able to tell where the 93 ended up moving to. What we can tell, however, though, is where the 60 came from. And so rather than this first value be unsorted square brackets number square bracket index, what we want to do is we want to utilize then the original location. So in other words, we will use our locations vector to specify what number was at, or rather where that number came from. So what the original number or what the new number was and where it came from. Sorry, I got a little tongue tied there. So here what we're going to do is we're going to specify essentially that the value at the unsorted numbers at the original location, and then we want to specify where it came from. And so specifically here, where did it come from? It came from locations square brackets index, and then where did it move to? So for the second argument, what we want to do is we want to specify locations square brackets index, and then ultimately for the third argument, we just simply want to specify the index. All right, so let's go ahead and build this. And we'll go ahead and run this. We should now have a second table now. And you'll see that the 60 moved from index 98 to index 0. Now, the point that I wanted to make here is instead of utilizing the unsorted numbers, square brackets location, square brackets index, we can now simply change this to sorted numbers, square brackets index. So the important thing to note here is that sorted numbers is the newly sorted array using our unsorted numbers, square brackets, locations, square brackets, index. And to prove that to you, we're going to build this one more time. And we're going to rerun this one last time. And you'll notice that once again, 60 moved from index 98 to index 0, 61 moved from index 21 to index 1, and so on. And what you can do is you can utilize one of our earlier output files to be able to verify this. So what I would encourage that you do is run one of your earlier functions, one of your earlier sorting algorithms, and look at the ascending, and you'll see that 61 is in fact the second value. Now, we don't know which one of the 61s this was without looking at our table to discover that it was the one that was found on row 21, or rather index 21, which corresponds to row 22 in our file. And it, in fact, was the one that was moved to position or index 1. Likewise, this 61 moved from the 32nd row to what amounts to the third row, or index 31 to index 2. So hopefully you found this video useful. What I want you to do now is I want you to take a look at your other functions, the sort double and the sort char. Notice that they have the exact same function signature. So what I'm going to do briefly is encourage you to pause the video here and go ahead and complete your sort double and your sort char and think about what makes those different. So I'm going to pause the video here for a little bit, and I will see you on the other side. Welcome back. Hopefully you found the changes that need to be made. A quick note, I did make one additional change that was merely for convenience. This variable was originally called original locations. I just shortened it to locations because that got a little bit unwieldy. But essentially the only change that was required to be made within your sort double was merely changing this convenience variable from int found value to double found value, because your numbers vector was now a double. If you had decided to work solely with indexes in this one, then you actually didn't even need to make that change. Likewise, in our sort char function, which simply sorts individual characters, then what you would do here is first change your algorithm such that everywhere there were numbers, you would change it to chars. You could use Control H like I did. And then, of course, the second minor change would just simply be to change the int found value to char found value. Note once again that I have shortened this variable just for convenience. Everything else, believe it or not, is actually the same. Once you've made your changes, go ahead and build it. And what we will do is, in an additional video, we will test these functions as well as build the sort word. At this point, you want to work toward getting your core demo working, as well as we are going to use our own string compare function to be able to ultimately sort our words. Hopefully you found this video useful. As always, if you have any questions or comments, do not hesitate to email me, and thank you for watching.